Yes, sir. Live stream started, sir.
Sorry, and you give co-host to the HOD ma'am, sir.
Yes, sir. Yes, sir. Given.
Okay, okay, sir.
Sir, am I audible?
Yes, yes, ma'am. You are audible.
Yes.
Yes,
Okay.
First, I'm giving host to you, sir.
Yeah, I'm just wondering that shall I just directly start? I was confused actually. Or you are waiting for someone?
Good evening, Dr. Praveen Prath. Good evening, Doctor.
Thank you. Good
Praveen
evening.
Prath. Yeah, good evening. I'm Sudha. Welcome to SRM. Sir, Nadraj sir. Sanju
Yes,
ma'am, please start, ma'am.
Yes, ma'am.
Okay, ma'am. Okay. So,
Madam, 1 minute, madam, 1 minute, 1 minute.
yes, yes, ma'am.
Good evening to all the participants. I take great privilege in welcoming Dr. Praveen Pathak, Scientist EE, Homi Bhabha Center for Science Education, Tata Institute of Fundamental Research, TIFR, Mumbai. And I welcome all the research scholars, faculty members, and students for this webinar on applications, mobile smartphone based classroom experiments. Thank you. Have an enjoyable learning. Yes, ma'am.
Yes, yes. Good evening, one and all present here. I, Dr. Sanju Rani from Physics Department, SRM Institute of Science and Technology, Ramapuram campus. On behalf of SRM Institute, Science and Technology and the Department of Physics, I welcome you all to the webinar on Innovation Technology and Application Smartphone-Based Classroom Experiments. At this occasion, I would like to introduce my department to you all. SRM Institute of Science and Technology is one of the top ranking institutes in the India with over 38,000 students and more than 2,600 faculties across the campus, offering a wide range of undergraduate, postgraduate, and doctoral programs in engineering, management, medicine and health science, and the science and humanities. The institute has academic tie-up with leading corner universities like MIT, University of California, US, University of Dundee, and Oxford University of UK. Our institute is accredited by National Assessment and Accreditation Council with A++ grade in the 2018 and get placed A category by Ministry of Human Resource and Development. Now I would like to request to Dr. L. Sudha, Professor and Head of the Physics Department, who is the convener of this program also, to give a welcome address and the overview of our department. Ma'am. HOD ma'am.
Yes, ma'am. Yes, ma'am. Can I see my screen?
Yes, ma'am.
Am I
Yes,
audible
ma'am.
to you?
Yes,
Audible,
ma'am.
ma'am.
I request Dr. Praveen Pathak just to bear with us for 2 minutes, sir.
Yes, sure. No problem.
Thank you so much. Just a glimpse of the Department of Physics, SRM IST Ramapuram campus. This was established in the year 2004. Excellence and research and teaching has been the hallmark of our Department of Physics. Highly qualified and dedicated faculty members we have. The department offers BSc Physics, PhD programs, and research scholars are actively engaged in research under the able guidance of supervisors. The department had 3 research projects funded by Department of Science and Technology, Science Engineering Research Board, Government of India, and 2 projects funded by SRM IST to the tune of more than 80 lakhs. There are 3 research laboratories in the department: Crystal Growth Laboratory, Multiferroics, and Computational Physics Laboratory. Faculty members have published 80 papers in SCI Scopus indexed journals in the last 3 years of high impact factor. The programs offered by the department are shown in this slide. And the curriculum of SRM IST is framed in such a manner that to suit the needs of the different branches of engineering. As you can see from this, semiconductor physics is offered to BSc, BTech, Computer Science and Engineering, Information Technology, Electromagnetic Theory, Quantum Mechanics, Waves and Optics theory is offered to Biomedical, ECE, Electronics and Communication Engineering, Electrical, Electronics Engineering, Mechanical, and Mechanics of Solids is offered to Civil. Fundamentals of Physics for Computer Science and Business System. This is a branch we tie up with TCS. And apart from this, we also handle applications of nanotechnology, industrial nanotechnology for 3rd year EEE students and mechanical students. And this is a team of physics and specialization PhD area covers X-ray crystallography, dielectric studies, crystallography, crystal growth, semiconductor structural study, spectroscopy and molecular docking, nanotechnology, nonlinear dynamics, energy conversion applications. And this is the details of the projects. And we have, apart from this, we have international research collaboration. I had been to Shizuoka University Research Institute of Electronics as a visiting professor for 2 months. And also our faculty members are having collaboration with University of California and in Indira Gandhi Center for Atomic Research, Kalpakkam. This is a photo of the Japanese scientists visit our department. This is our crystal growth research laboratory, material characterization research laboratory, physics laboratory 1 and 2. And we have, the department has a science association called as Forum of Sciences. And every year the Forum of Sciences organizes mini project contest, guest lectures, seminars and workshops. And this is, every year we tie up with Tamil Nadu Science and Technology Center for organizing this workshop, this mini project contest. And they bring a mini planetarium and a tabletop scientific experiments to the campus. And the projects, the students' projects are assessed by IIT professors from IIT, Anna University and reputed institutions. And we always welcome the projects for quality, innovation and originality of the projects. And the students, our students, they don't buy the projects from the commercial markets. And we invite for this competition, we also invite nearby school students. So far 1,500 students from schools in Chennai have visited our campus to see the mini projects and also the mini planetarium brought by Tamil Nadu Science and Technology Center, and they were highly motivated on seeing the projects. And we consider this program as extension program. And we, apart from this, we organize National Conference on Hierarchically Structured Materials from the year 2013. And every year we get funding from Department of Science and Technology, Council of Scientific Industrial Research, DRDO, BRNS, Tamil Nadu State Council for Science and Technology, Science City, and also every year we conduct a workshop on material characterization, wherein we give hands-on training to the research scholars and faculty members. These are the programs we have conducted. We have conducted more than 40 events from May 2020-22 till date. And we recently conducted international conference on hierarchically structured materials. The conference proceedings were released by our Honorable Chairman, SRM Group of Institutions. Inaugural function and a special address was given by Vice Chancellor of SRM IST, and the presidential address was given by Co-Chairman SRM Group of Institutions. These are the photographs of the functions. School students witnessing the projects. And apart from this, we also conduct Indian Nuclear Workshop on Indian Nuclear Program in association with the Indira Gandhi Center for Atomic Research, Kalpatram. Thank you.
Thank you, ma'am, for giving the nice overview of our department. Now, I would like to request to Dr. Nadraj, Assistant Professor, Department of Physics, to introduce our speaker to our audience. Sir?
Yeah, thank you, ma'am. Yeah, I am happy, privileged to introduce today's chief guest, Dr. Praveen P. Pathak. He completed, he is the Scientific Officer E, Homi Bhabha Center for Science Education, Tata Institute of Fundamental Research, Research TAFR, Mumbai. He joined the Homi Bhabha Center for Science Education, Mumbai in 2005. He involved in physics Olympiad program as a lecturer, evaluator, and academic coordinator. Theory for core group, very bright high school student across the nation. He has guided 8 UG students for their project under National Initiative on Undergraduate Science program. As such, 5 projects have been completed and presented in peer-reviewed journal and in international conferences. He is working as a tutor for mechanics and waves at Center for Excellence in Basic Sciences, University of Mumbai, and Department of Atomic Energy, Mumbai from 2007 onwards. Currently, he is the instructor for statistics mechanics. He has published more than 10 research paper in reputed international journal with a high impact factor. Only few are from the Physica A, Resonance, Physical Review B, Pramana, and then the approach in Crony-Penny model Prayas. So he also published a book, Indian National Physics Olympiad Theory Problem and Solution, in the year of during 2005 to 9. He has also presented a paper at the national and international conferences. The important conferences are International Workshop on Physics of Semiconductor Devices, IIT Mumbai TAFR, in the year of 2007. Indian Association Physics Teacher and National Symposium on Impact of Nanoscience and Nanotechnology on Physics Education, in the year of 2006. International conferences on mesoscopic and disordered system, IIT Kanpur, in the year of 2006. International conferences, mesoscopic and disordered system, IIT Kanpur, in the year of 2006. And also international conferences to review research in science, technology, and mathematics education, HBCAC Mumbai. He also presented participated. He also participated and presented a paper as invited speaker at the various online offline event all over the nation. So with this credential, I invite sir to take over the session. Thank you, sir. So sir, please.
Yeah, thank you very much for this generous introduction. Before I begin, I want to know that how much time do I have?
Sir, so actually 1 hour, sir.
1 hour. Okay. So I can go up to 6:10, 6:05 or something, right?
Okay, sir.
Yeah. Okay. Thank you.
Sir,
So
just to inform you,
thank
your
you very much.
slides are little blurred. Sir, your slides are
Still blurred?
Yes.
Yes, sir. Little blurred.
Okay, I will have to quit, and quit means I have just to quit this screen and join again. Probably that will fix. How about it now? An improvement?
No, sir. It is blurred, sir.
It's still blurred?
Yes, sir.
Just give me 2 minutes again. Okay. How about it now?
Yes, sir. Still it is blurred only, sir.
Actually, I'm sitting in the remotest places of this country. So probably network is still weak here. Can I just again log out and join again? Will that be
Yep.
okay? It will take hardly 1 minute.
Okay, sir.
Yeah. Will you please make me host, co-host?
Yes, sir. Please, sir. Sir, given, sir. Yeah, now it is okay, sir. Clear, sir.
Okay. Okay, so I think without wasting any time, I will start, and I've switched off my webcam because probably that will also affect the quality of this talk. Is my voice clear, or is there an echo on that?
Clear, sir. Clear, sir. Your
Okay.
screen is visible. You are audible.
Thank you. So I will, I'm sorry that I am giving a talk on technology and innovation, and some technical problem has prevented me for presenting for 5 minutes. So I will hope that I can make up to that. So I will. So this journey for this topic started last year during lockdown, when each one of us is, is at home for obvious reasons, and we wanted to do something. I wanted to teach someone, and some college requested me to, to prepare some experiments which a student can do at their home. And that's how actually I started exploring this field, and I thought, why not to do something with the smartphone? And I realized that this field is hello, is someone saying something? Sorry. Okay, I hope that is clear now.
Sir, I will take
Yeah,
it.
okay, someone was actually speaking. So this, so I was amazed to see that we can do lots of experiments, science experiments, starting from middle school, primary school level till very advanced level. So here I will be presenting some of the experiments which you can do at your home, and you can also do it in your lab, some of the experiments. So so let's go ahead with that. Okay. As Benjamin Franklin said, that tell me and I forget, teach me and I remember, involve me and I learn. So if you want to learn something out of this talk, you want to try while I'm also carrying out those experiments, you are welcome to install these apps here. I will be mostly using these 3 apps here. One is this Arduino Science Journal. You can go to Android or iOS, you can download this. And there's another one is Fifox. It is written as Fifox, but pronounced Fifox. It is developed by Sebastian Stocks from Germany. And one more app is Wave Editor. It is on Android, and the counterpart of this app is Twisted Wave Recorder on iOS. Okay, so what a smartphone can do in your physics lab. You know that your smartphone can measure the light intensity falling on it. It can detect the frequency of sound it is receiving. It can detect the sound level, means decibel, means intensity of sound falling on it, or whatever it is receiving. It can detect the magnetic field around it. It can tell you reading of barometer. It can tell you how much the pressure around it. It can also tell you temperature. And accelerometer. Accelerometers can tell you what is the acceleration of the phone, which if it is moving. And everything is in just in your pocket. These two things, barometer and thermometer, these are only in high-end phone. They are not available on low-end phone. Like something, if you buy something beyond 40,000, I think you will get those. It is definitely in iPhone and iPad. Okay, and they are almost no cost, because you have already paid for the to buy that phone. So you don't have to buy, you don't have to pay anything to carry out these experiments. But let me just give you a caution that experimental measurement which you will carry out, they are of reasonable accuracy. They are, you can verify the scientific principle, but sometimes you don't want to, if you want to have a very good result, very precise result, very accurate result, probably the readings from the smartphone will not be for that. In some cases it will be, but not all. Where it is useful, where it will give very precise value, I will tell you as I'm cruising around it, around my talk. The way I will be carrying out this talk is, you can see these 4 sensors I have listed here. Accelerometer, audio amplitude sensor, means it will tell you the intensity of the sound. Magnetometer, and sound frequency sensor. So I will give you examples of each, examples of the experiment which you can use, which you can carry out using these sensors here. So let's see how much I can cover in this 1 hour. Okay, so starting with accelerometer, your phone can measure the acceleration. I have already told you. You use it in gaming. You use it actually when you tilt your phone, or you. So how does the phone detect that you have tilted it? Actually, it detects that if it is rotated, at some angle, so then there is a gyroscope inside it, and there is a small mass suspended between 2 metal plates. And when you are moving the phone, the mass moves. Hence, the capacitance associated with. Sorry, again someone is interrupting. Can you request everyone else to mute their phone, please?
Yeah, dear participants, so please mute your mic.
or I will tell you one thing. You can mute everyone if you are a host, and then then you can unmute me.
Yeah,
Probably
I
that
will
will
mute.
be.
I will
Yeah.
mute it, sir. I will mute.
Just take half a minute. Okay, so I will go ahead. Am I audible?
Yeah, you are audible, sir.
Okay, so you use it, and actually when you're using Google Map, it tells you the acceleration by it is moving, and it tells you in all three directions. So you need to note down these directions. See, when you so across the width, the mobile phone is the X direction. Across the length, it is Y direction, and anything coming out of the plane is the Z direction as it with the phone. So if you want to know that what is the acceleration, and when you are moving phone towards the X direction, it will give you AX value. It will also give you AY and AZ value. But if you are interested just in one axis, that also you can get. So to give you a very basic idea of that, here is the screenshot of the app FFox. So you can see there is a tab called acceleration without G. What is the meaning of without G and with G? That will be clear to in a minute. So you place the phone on the floor, and then you click this acceleration without G. Okay, so there is a play button here where you can see there's a pause button here, two parallel lines. This is the pause button. So you can start and you can stop the recording of that. And when it says that without G, it means it has included the 9.8 meter per second square in the reading. So when you place the phone on the floor, it will give you, since it is not moving, it will give you 0 meter per second square for linear acceleration X, Y, and Z, and the absolute acceleration, which is the square of all these components here. If you click on acceleration with G, the second tab, it will tell you what is the acceleration in the Z direction. Since Z direction is coming out of the plane, you have placed the phone on the floor. So in that direction, the gravity is acting. Hence, you will get the linear acceleration, which is close to 9.8 meter per second square. And there are other tabs here which you are welcome to use. I don't have to guide you right now, but let's see. Now, I'm telling you that this smartphone gives you a way to measure the acceleration. It gives you a way to measure magnetic field, to measure the sound frequency, to measure the sound decibel meter, and the light intensity and all. But it is the physicist's job to figure it out that what you can do with these things. You have a tool. Now you have to make it. Now you have to make a good use of it to perform an experiments. A smartphone will not give you experiment. A smartphone will only give you the readings. It will only give you the readings of the quantity or the variables which are associated with that. But it will not tell you how to do the experiment. The experiment you have to think what I can do with these measurements. That's where your creative minds will come up. So can I use this accelerometer for the time measurement? Let's see. This is a very simple activity which you can do in your class. So it is on the reaction time of human reaction time, and it is actually defined as the time between a stimulus and a response. So for example, if I will show you lots of cards, colored cards, and I ask you to identify the colors of those cards as soon as you see it. So how quickly, how fast you recognize the color of those cards, that will be your reaction time. Who has the fastest, who has the lowest reaction time? It means who is the quickest enough in our Indian cricket team? Probably you'll be knowing. Okay, he's Mahendra Singh Dhoni. So when Mahendra Singh Dhoni is behind the stumps, Kuldeep Yadav has balled. Now he catches this ball in how many seconds? Let's see, it will tell you it was 92 centimeter away, and it is at, so reaction time is 0.08 second. So Mahendra Singh Dhoni is 0.08 second fast. So he can catch a ball in as much as fraction of seconds. Can I measure the reaction time of not Mahendra Singh Dhoni, but me, you, and anybody else? I will make the use of accelerometer here. So here I'm using the accelerometer for the time measurement. I'm not using it to measure the acceleration. It's a very simple activity you can perform. That let someone hold this phone, okay, with FFox accelerometer tab on, and let her drop this. And when this person, who is actually, you can see these two fingers here, when she catches this phone, not ball, not the cricket ball, but the phone. So that should be the reaction time from starting when it started to fall and she caught it. So this much time we have to calculate. Now I can make the use of accelerometer here. How? So while it is falling, while it is freely falling, the acceleration is close to 9.81 meter per second square. And if I can detect that for how much time this acceleration was 9.81 meter per second square, this will be the reaction time of whoever is performing the experiments. So let's see this. Okay, so I am holding the phone here, and someone is trying to catch this. Actually, she's my wife. She's trying to catch this, and let's see. So I have actually, I'm sorry. So on left side, you will see the screenshot of the app as it is recording, and on the right side, you will see the experiment. So I have started this accelerometer tab, and it is telling me you can see all the x, y, ax, ay, and az, all three values of acceleration. And now I will drop it without warning her, and she caught it. Now, how much time did it take? For that, I have to go to, since it was falling in which direction? It was falling in the y direction. So I will go to that AY tab, linear acceleration Y tab, and this is the flat part which you are seeing. Probably you can see that. And you go to these two ends of this flat portion, and you can see this is 4.52 to 4.39, almost like 0.18 second. So phone was in air for 0.12 seconds, sorry, for 0.12 second. Now this is the very small fraction of time which you are able to measure using the accelerometer. Isn't it amazing? This much of time you cannot actually, you need some sophisticated timer for that. But making the good use of accelerometer, you can actually calculate that. I'm just giving you an example. You can use this, you can drop a ball, and if you know the distance, you can let's say that you can associate with this, you can actually drop it for some known distance. Okay, and by applying equations of motion, you can calculate acceleration due to gravity. Very simple activity. You don't need a video, you don't need anything. Just need to see that for how much time the acceleration was 9.81 meter per second, and that will be the value. I just want to confirm at this point, was my video visible?
Yes, sir.
Okay, thank you. Okay, so this is one good use of accelerometer. Now I will go to another sensor, this audio amplitude sensor. And for this, using this, I'm going to measure the height of a building. Okay. Now, how to do that? So let's see. Okay, suppose that you throw a ball. So I'm just giving you a theoretical background behind this activity right now. So you throw a ball, and at some point, actually, it will start turning, and it will come back, and it will collide with, it will have some inelastic collision with the floor, and then it will keep bouncing. And it will keep bouncing, and in every bounce, this height will keep decreasing. What will happen to this time? Delta T1 and delta T2. Delta T1 is the time difference between first collision and the second collision. Okay. And delta T2 is the time between second collision and third collision. And from our common sense, we know that this delta T1 will be greater than delta T2 and all. I will show you a video out of this. If I assume that the coefficient of restitution is constant for every bounce, it means in every strike, when the ball is colliding with the floor, the energy is lost. And that energy lost is same in every bounce. This is my theory. Then I can do some mathematics here. I'm saying that E0 by E1 is equal to E1 by E2 because coefficient of restitution is constant. And each bounce, same fraction of energy is getting absorbed by, it is getting lost. So E0 by E1 is equal to E1 by E2 is equal to E2 by E3. And what is E0 and E1? mgh0, because in the E0 is mgh0. What is E1 is mgh1, and so on. So you give some energy to the ball to go up to the H0 level, and then it is dropping. So this mg will get cancelled, and from this previous equation, you have h0 by h1, h1 by h2. Now you apply equations of motion, half gt square, and you will have g by 2 delta t1 square by 2, because this so it took half of this delta t1 time to reach up to this height, right? What you don't have is t0. What you don't have is the starting time, t is equal to 0, right? That you don't have, because your phone cannot measure that. So I have actually not told you why I'm using phone here. Okay, if you have, and so you can put these h1 and h2 here, and you will have h0 in your hand. So I can tell you the initial height till which the ball has gone if you give me delta t1, delta t2. Okay, there's some background noise again.
Nataraj sir.
Okay, what you can do, as I told you, you can
Sir, Nataraj
mute
sir.
everyone else.
Yeah, tell me, ma'am.
Sir, how many times, sir?
You can just mute.
Muted all, ma'am.
Okay, now I have a, thank you very much. That will be okay. Thank you very much. So,
sir, Nataraj sir, just a minute, sir. Praveen sir, just a minute. Nataraj sir.
Yeah, tell me, ma'am.
No, sir. All the mics are not muted. You just check the participant list.
no, I think everyone is muted.
Mithilesh.
Mithilesh, I tried many times, ma'am, that I unable to mute the.
Yes, you better remove him, sir.
Okay, ma'am.
Sir, please proceed, sir. Praveen sir, please proceed, sir.
Okay, I started actually speaking without unmuting myself, so I apologize for that.
No
Now,
problem.
where the smartphone is coming to that? This is a simple experiment, but this is amazing if you can just throw a ball, and let's say that ball comes back from the top of the building. Okay, you are standing on the ground, you're throwing a ball comes back from the top of the building without hitting any other part. And if you have this delta t1 and delta t2, you can tell me the height of the building. Okay, it doesn't matter how tall the building is. You can always have this delta t1 and delta 2, and you can tell you the initial height. So let's perform this activity. I'm going to use a wave editor. Okay, this app is called Wave Editor for Android, and it tells you the sound intensity. So when ball is striking the floor, ball is striking the surface, it will tell you, it will give you a peak here. Okay, it is recording actually sound, but it is giving you the waveform of that sound. So it will record a peak at that point. Then that peak will keep decreasing. And again, that ball is hitting the surface. It will again give you the second peak. As you can see, the distance between these two peaks is larger than the distance between these two peaks. So let's see this experiment now. Okay, so what did I do here? I'm throwing the ball. I'm standing in a room, and I will throw the ball so that ball comes back without hitting the ceiling, and it comes back. It will have an elastic collision with the floor, and on the right side, this app is recording the sound. Okay, just go quickly. I will just take 1 second in this. You can see the kind of resolution you are getting here. A smartphone is very sensitive to any kind of sound which it receives. It tells you exactly at what point that sound has come and what was the intensity of that. I don't need the intensity of sound here. I just need to locate the position of these peaks here, right? So I will go back to that app and I will zoom it, and then I will get these values. Actually, you can get up to millisecond resolution here. So there was a third decimal also here, but I don't need for the purpose of this experiment, so I'm not noted down. So for that particular trial setup, this was 4.23, second peak was 6.23, 7.23. You subtract this delta T1 and delta S. So you will subtract 4.23 minus 6.23, and you have these values. And if you put these numbers, the actual height will come out to be 3 meters, close to the 3 meters. And this was 2.94, and the actual ceiling height was close to 3 meters. Yes, someone has raised hand. Please ask question if you want to. Or you can write in the chat. Some Redmi has raised the hand.
Okay, we will have a discussion at the end, sir.
Okay. But they can, I don't mind if you're there, if they want to ask question, they can certainly do that by raising their hand. Okay. Okay. Om Prakash Barik has raised hand. Please ask. You can unmute and ask if you want. Okay. I think, I don't know, maybe there's some technical problem, so he's not asking. So maybe I will go ahead. Okay. Okay, so next one, I will give you example of the magnetometer here. And the magnetometer is actually, it gives you very precise reading. So I was telling in the beginning that why sometimes you cannot use mobile phone for very precise values. So accelerometer doesn't give you very precise values. It is very sensitive. So if you just move your phone a little bit, it will give you change in the reading, sometimes which is not desired during the experiment also. But audio amplitude, the timing, it has got a good resolution up to millisecond. Okay, and the magnetometer, it is inside the Hall effect based sensor is there, and that also give you very, very accurate readings. Just put your phone in some direction, in some predefined direction in which the Earth's magnetic field is there, and you can actually get up to micro Tesla, up to 5-6 micro Tesla reading it can give you. It is very small and it can give you very precisely. So that's a good use of that. Let's see some experiment based on magnetometer, which you can perform at your home. So using this experiment, I'm going to measure the acceleration due to gravity again. Okay, this is a unique experiment I have found where you can actually combine electricity and magnetism, actually the inverse cube law and mechanics. So let's see that. You must have maybe from your higher secondary school level physics, you may remember this formula, that magnetic field of dipole moment m from distance x away from it. So let's say that you want to measure what is the magnetic field if you keep a magnet at x distance from it. So this is mu0 m by 2 pi x cube. Okay. And how a smartphone can use that? You actually note down first you have to figure it out where the magnetometer is present in your smartphone. Okay, so for that you move some magnet across the length of this magnetometer and see where it is maximum. So you have got some location of y, and then you move the magnet across this length, x length, and then you will have that coordinate of also wherever it is maximum, you will wherever these two lines are crossing, that will be the location of magnetometer. For my phone, which I was using Redmi Note 7, the magnetometer is located almost like 1.2 centimeter away from the top, and 1 point almost I think 4 centimeter away from this length. It is away from that. I believe in most of the smartphone it is there only. There is one more Samsung M13 or something. This smartphone is magnetometer is located somewhere here where this red laser light is visible. Okay. So you first you locate where your magnetometer is present. Then what you do? That you keep your magnet X, let's say that some 10 centimeter away from it, and because this formula is valid for large distances only. Okay, X should be large enough. It should be very large than the total length of actually half length of the magnet. So let's say that magnet is 2.5 centimeter long. So you keep it somewhere between 10 centimeter onwards. you keep it 10 centimeter away from it. So for each x, you will have some bx here. So you keep moving it in steps of 0.5 centimeter or 1 centimeter, and you will have bx versus x data. And once you have that bx versus x data, you plot this bx versus mu naught m by 2 pi x cube. Sorry, mu naught by 2 pi x cube. And that should be linear. You must have been told by now in your experimental courses that you have to plot a linear plot, and you don't plot bx versus x. This is a good lesson you will learn in your experimental physics, that you don't have to plot bx versus x, because that will be very troublesome to interpolate and all. So you plot bx versus 1 by x cube along with mu naught by 2 pi, and the slope will give you dipole moment of the magnet. You can take actually any magnet. You can take very small magnets like neodymium magnet. You can take those magnetic stickers on your which you put it on your fridge, or any other object, any other magnetic object. And this smartphone magnetometer is so sensitive that it will give you some data there. And very easily you can calculate this dipole moment here. And you will also verify this 1 over x cube law. If it is not linear, it means you have made some mistake in your readings, or you have incorrectly located your magnetometer. Then, using this m value, let's say that instead of placing it some x distance away from it, you drop the magnet away from the mobile phone or towards the mobile phone. Okay, so now you are not manually moving it. It is actually under the influence of gravity. Magnet is falling, and everything else will remain same. Mu naught m by 2 pi. What will change here? Since I am dropping in z direction, so I have replaced x by z here. And since it is moving away from that, so you will have, let's say that initial distance was z naught. Okay, and it is moving towards it. I'm sorry, that should have been plus here, z naught plus gt square by 2, because in the figure it is shown that it is moving away from that. In the experiment, actually moved towards the phone. So it is correct for the experiment which I performed but for this figure, as far as this figure is concerned, this should have been z naught plus gt square by 2. Okay, this is just this equations of motion here. You apply as equal to ut plus half gt square, and you can replace this x by this distance here. How you can measure acceleration due to gravity? You can linearize this equation again. You take this 2 pi z naught, this whatever is in the denominator on the left hand side, and then you plot this quantity on y-axis and t square on x-axis, and slope will give you g, acceleration due to gravity. In this experiment, you will need m here, dipole moment here. From where do you get this m? From the first part of the experiment. Okay, this is a beautiful activity. I found that you verify so many things. You verify 1 by x cube law, you combine electricity and magnetism to mechanics, you also verify equations of motion here, and then you also verify that value of g is this. This 4 or 5 things you can do here. Now let's see that. So I will show 2 videos here. One for this part 1 and one for this part 2. Then I will also show you the data. So any experiment which I'm showing you, that will come with some proper data here. Okay, I have done everything at home without any sophisticated instrument, and then I'm giving you that. So I believe that you can do it, and you can also do at home. This is for part 1, where I'm measuring the dipole moment. So I have already located where my magnetometer is located in the phone. On the right side, you can see the screen recording. I have started this magnetometer tab. The app which I'm using is PHYPHOX app here. PHYPHOX, PHYPHOX. And then I start this play button, and it will start recording. Yes, yeah. So it started recording. I will keep it some distance away from it, since I have a scale here. So I will always know where I have kept it. And since I'm moving in the x direction, so you need to pay attention to this magnetometer x, the first graph which you are seeing here. Okay, I'll just quickly, fast forward it. and I pause it. I can export this data in a computer and do this Excel and all, and I can plot a linear graph here. So I can share here, I can save it. Okay, I can go to each step and I can note down these values here. So you can see that it can measure up to micro Tesla, up to 200 micro Tesla. I could took it. Actually, you can go beyond that also, but that will probably mess up with your ratings. So I will advise you to only go up to 100, 200 micro Tesla. I'm sorry, there's some problem with my screen, so it was stuck. I will share again. Okay, for the second part of the experiment, where I'm dropping this magnet. Don't worry, I will hold it. I dropped it, but the drop is not clean. So you can see that on the way it actually magnet got tilted. Yeah, this was sort of better. And I go to the relevant portion where magnet was dropping. I just need BT versus T data, means magnetic field versus time data. And then I will extract this part of the data and process it in Excel and all, and I will do that. Okay, so it has two parts. This to obtain the dipole moment and obtain G. For the first part, if you plot Bx versus this one Yx cube data, you can see this very good linear graph, and the slope will give you the dipole moment. So for this particular trial, the slope was 15.44. This was the dipole moment. When I took 12 trials, so the reading was close to 15.67, and with some uncertainty associated with that. For the second part, where you have magnetic field versus time data, you plot it with respect to whatever is on this y-axis versus t square, and you can see this is also very linear. It will start going, away from this straight line when actually at this point it is in my hand. So this, you can see that this whole drop period was somewhere between 0.7 to 0.8 seconds. 0.7 to 0.8 seconds. This very small time period. And for that very small time period, you can actually measure it. So this is actually very good quality of this smartphone. You can actually go up to millisecond in terms of second. When it comes in time, you can go up to millisecond resolution. You can see for this particular trial, the value was 9.79. And when for the all 12 trials, it was 9.78 plus minus 0.18 meter per second square. In Mumbai, the value where I was doing that is close to 9.79. Hence, it is an untraditional way of combining magnetism and gravitation. I think it is a very good teaching tool. You have to perform very carefully. You need some skills in finding out the location of magnetometer on the phone, because if you do not locate it properly, you will mess up the results. You can also use very sophisticated setup in the lab where magnet is actually, you can fix it with help of electromagnet, and then it falls through a pipe. So there is no tilt. It is not, it is always remaining along the axis. and restricted up to, students up to, undergraduate level can perform this experiment, I believe. And again, it is no cost apparatus. You just need a magnet and a smartphone. Okay, so for the next part of the talk, I will use sound frequency sensor. Okay, so sound frequency sensor. So it can measure the, so I already showed you the sound intensity sensor in which you can measure the intensity of sound. Now this next sensor which I'm going to use is, it can tell you the frequency of sound for a very obvious reason, because your phone is actually, basically it is designed to speak and talk. So it is very sensitive for the range of up to 400 hertz. Okay, because this is the level where we speak. Now I have the sensor. Now what to do with that? Of course, it will tell you the frequency of sound which you are speaking. But as a physicist, as I said, that it is your physicist or it is your creative mind which it should come up and it should tell you that what I will do with this measurement, what I will do with this measuring tool. So here is the activity or experiment which I'm proposing. This is suited for, you can do it at home, or it can be also done at a very sophisticated level in the lab. So I have a metal rod. This is actually an aluminum rod. I'm going to hit it at the end by some non-metallic hammer. In this case, it is actually wooden hammer. And what happens then when you hit a rod? I'm sure you must have seen that, you must have experienced that, it produces some kind of sound. There's some humming sound. That kind of sound actually it is being produced. If you place a finger in the middle part, let's say that you place finger at the L/2 distance at the center of mass, then what happens that there is a sound it is being produced in the rod, and then you placed your fingers, you have provided some antinode there. So particles at that point cannot vibrate. So you provided some antinode there. Since there is an antinode, so this kind of waveform will be formed. Now I can apply this whole thing, this whole wave which you are seeing. This I am representing some sound wave here. This is actually λ/2. Okay, because this half part is still there, which I have not drawn here. This whole thing is λ/2. So total length is equal to λ/2. What I can measure beforehand is the length of this rod, which for this particular setup is 44.5 centimeter. Okay, and then you note down what is the speed of sound in aluminum, which is square root of Young's modulus divided by density. Go to Wikipedia, get down the Young's modulus of aluminum and density, and so this is about 69 GPa gigapascal, and it will give you 5055 meter per second. Now you have velocity, you have lambda. From this equation, you have lambda, you have velocity. What you can have is the frequency. So if my hypothesis is correct, that by hitting the rod, you are producing some kind of sound, and you are providing this kind of antinode here, and there is whole length is actually λ/2. This particular setup, if I'm able to measure the frequency of that sound, it should come out to close to this number. Okay, 5670 hertz, 5679 hertz. So let's see that. Okay. So I've kept a phone on the table and I have a rod in my hand, and I'm actually going to hold it at some midpoint, not some midpoint, there is only one midpoint. And then I'm going to hit it. On the right side, you will see the screen recording. So this particular part is called audio spectrum in phyphox. Audio spectrum. This is here. It actually gives you it actually gives you Fourier transform of all the sound frequencies which it is receiving. In a sense, if you do not know what is Fourier transform, you just need to see this peak frequency here. So it will tell you that which is the dominant frequency it is receiving. It is receiving frequency, when someone is talking in my room, that also it is receiving. So you can see all this. It is going from up to how many? This is 1,000 hertz or 10,000 hertz or something. Okay. But it is actually, you can see this peak frequency here. So somewhere here, the peak frequency was 46 hertz. That's what it is telling. Which is the dominant frequency in the sense it will tell you. You see that humming sound, and pay attention to this number here. 5671 hertz. Okay. I hold it at some other place, not at L. There is a third, because there are no standing waves are being generated. Again, I will hold it in the middle. Very beautiful humming sound, 5671 hertz is being produced. Every time it is able to hit the same frequency. So this was the screenshot. And what the number I was expecting, 5679 hertz. It's a good experiment, I will say. It is not the bad experiment. It is actually very close to the proper number I'm getting. Now you can figure out the sources of error here. Why this number is slightly away from that. However, the error is very small. No experiment will be without errors. There will be always some uncertainty. Theoretical result will always not match with the experiments. I will say if it is matching perfectly without any error, then there is something wrong you have done, either in theory or in experiments. The possible source of error can be, it may not be pure aluminum. The density may not be uniform, or there may be some mistake in the length, which I have measured because I have just used any length which has got 1 millimeter least count. Anyway, nevertheless, so you can always find, you can replace this. Now here's a small research project for you. You compare with aluminum, you compare with copper, you compare with any other iron rod, okay, and see whether, so what will make the difference is this thing, speed of sound in that particular metal. You can play with different length and you can see if you're getting any difference here. Just a small, possibility of research publication, I will say here. And you just need to use very small, some things which you can find at your home. The second experiment based on the same sensor, which I'm going to provide, is the measurement of acceleration. Okay, I'm sorry, I will skip this because I don't think I have much time here. Yeah, I have already, so I will skip this one, but based on this, I will show you something else. Okay. It is almost the same concept which was on the previous slide, which I did not show you. So this is the measurement of sliding friction on an inclined plane using Doppler effect. I'm combining now mechanics and the Doppler effect. I'm sure you are aware of what is the Doppler effect is. When some source is moving and let's say you are standing on a platform, train is moving in front of you, train is whistling a horn, train is blowing a horn, then you will see the change in frequency as it is approaching to you and moving past. It is actually when it is crossing you, you will see the change in frequency. And Doppler has given a formula for that, which you read it in your high secondary school level physics. It is basically, this activity is designed to convince the student that sliding friction is constant. It doesn't depend on the angle of inclination. So students have difficulty. There are a couple of research papers which actually say that students do not accept this fact very easily, that if I change the inclination of this inclined plane, then the friction remains constant. It is actually gravity which is actually making it to move with faster and slower velocity as dependent on theta. So let's convince how do I convince the student? So I slide some object here. In this case, this was a phone which is sliding on this wooden plank, and only for this one. Don't worry about this receiver phone right now. And I can write down, I can actually divide it into two components, y and x and y. And then I can write down the frictional force on this. And the acceleration can be written something like this. A is equal to g sine theta minus mu k cos theta. where mu k is the coefficient of kinetic friction. You linearize this equation again. You always have to linearize the equation if you are in a lab. As far as possible, you have to linearize that. Okay, that will ferret out lots of errors which you will be making in your experiments. And when you have to plot it, try to plot it on a linear fashion. So if I am able to plot a by g sin theta versus 1 by tan theta, the slope will give me mu k. If I am able to plot versus various thetas and various a's, so a by where there, if I change this theta, a will change, acceleration will change. I will plot a by g sin theta versus 1 by tan theta for various thetas, and the slope will give me coefficient of friction here, kinetic friction. Since it is sliding, so I'm calling it kinetic friction. This is not static friction here. Now the question is how to get A. By the way, your phone can also measure the angle. There is some angle meter in your phone. There are thousands of apps again for the angle meter. You can just go to phyphox here. So if phyphox, there will be some inclination tab, inclination, and you place it on a surface, it will give you the angle of that plane. So I measure the angle here, and then I actually start something called tone generator. So your phone can generate a tone here of any fixed frequency. So if I ask it to generate at 4000 Hz, it will keep generating that frequency without any interruption. So continuous sound will keep coming up. Now the source phone, which is sliding, it is generating some frequency f0, and then there is a receiver phone, which is detecting that frequency. Okay. I'm going to use for this particular app, for this particular task, I'm going to use Science Journal app, Arduino Science Journal. Previously, it was supported by Google Science Journal, but now Arduino has taken over. So it will tell you the frequency received by it. So now the Doppler effect will come into picture because source is moving towards this observer. And this f prime frequency that will keep changing because source is coming closer to this phone. I apply this Doppler formula for accelerated sources or observers, and f0 cs, where cs is speed of sound, minus 80 will come up. I can take this 1 minus 80 by cs here, and I put this minus 1 here. But this 80 is very small. A cannot be more than, even if you just drop it in the air, A will be 9.8 meter per second square. And T is not more than 1 or 2 seconds. When CS is what? Speed of sound is 340 meter per second. So this 80 is very small than CS. So I can apply binomial expansion here. Okay. And this minus 1 will come here. This will be 1 plus 80 by CS by using this binomial expansion formula. And f prime minus f0 will be this f0 80 by CS. Now, if you give me delta f, you already know by which frequency this source phone is sliding. So f0, you know. F prime, this receiver phone will tell you. It will also tell you that as for each time stamp, it will tell you that f prime. So you subtract it from f0 and you plot delta f versus t, and it will give you the acceleration, right? This is the job. So once you have A, you repeat this procedure for different angles, different theta, and you plot this quantity versus this, and you will have mu k. And if this slope is linear, that will convince the student that look, that mu k is constant irrespective of the angle of inclination theta. Let's see this. Okay. Okay, so I have two phones here. One is here at the bottom, one is here at the top. This is source in which frequency is being generated. And I will let it slide. You could also feel the change in that frequency. I will go to this recording. I will look at the part where it was accelerating. As you can see, don't worry about these dips because your phone has got some limitations. It cannot detect for every second, but it actually detects in some steps. But you can see it is almost linear here. Okay, and this maximum is 4018 hertz. So we started with 3000, 4000 hertz, and the maximum was received by this receiver phone was 4018 hertz. Okay, so this is the way to do that. Now I'm again showing you a graph of another trial which I took. It has got very nice linear graph here, where the initial frequency was 3800 hertz. Remember, for the first part, you have to plot between delta F versus t. So here it is. You can see it is not very perfect fit, but it is acceptable in when it comes to experimental settings. For this particular setup, the slope was 31.35, and the number is coming out to be 2.86 meter per second square. For the second part, when you have to plot it for various thetas. So I repeat this procedure for various thetas. I will have A and theta, and then I will plot. Then this is the plot A by G sin theta versus cot theta. You can see this is the blue line here, which is from the experiment. Now, who says this 0.27, which is the value of mu k I have got, the linear coefficient of linear kinetic friction, is correct? So simultaneously, I recorded this video on and then I processed something called tracker. So tracker actually you can track the object, and it will tell you what is the acceleration velocity of that object. Just process some video and it will tell you with proper coordinates. If you are able to process it will tell you the video. It will tell you the values. So for this, from that video analysis, the red line is for that video analysis, and the green line is, blue line is from the Doppler experiment. And using that, the value it came out to be 0.29. Okay, so not that bad result. I will say it is still under a acceptable range of 10%. It is a good result, I will say. This data is located here in this paper, which is at the last slide. You will note down if you want to. So these are the two experiments which I showed you using a frequency sensor here. And now I'm almost at the end of my talk. Yeah, I don't have, I have only 10 minutes. Some experiments I was able to show you. I have almost exploited all the experiments. There is one thing is remaining, light sensor, which I cannot show you due to shortage of time here. But it is not limited up to classroom settings, and you can actually perform a very sophisticated experiment also. Have you ever put a water drop on your screen of your phone? If you put a drop, it will show you this kind of structure here. And the lines, grid lines which you are seeing, this is actually pixel of your screen. This is a very recent paper. It came in physics teachers, in which the gentlemen were able to calculate the density of this drop just by looking at this picture. It's a beautiful paper. You should look at it. You can also make a spectrograph. This is a spectrograph using this smartphone. You don't need those complicated darkroom setup. You don't need those, I will say, so it has got some grading here, but that complications of that whole spectrograph has been replaced by just by this smartphone. And the references at the end of my slide, so you can see. But more revolutionary, I am thinking that there's lots of uses in medical science. There are apps which will tell you the heart rate, heart rate. There are heart rate monitor. There is recently it has come SpO2 level in the pulse oximeter, which you buy something like for 1,000 rupees from your market. There is an app which is I think it's called Clean Sex or something, that will tell you SpO2 level. Okay, this is a very good app. You should check it out. I have tested many times, and I think the readings are pretty accurate. But I won't advise you for for any medical readings. Means you can use it for a teaching purpose, but still I think they are in nascent stage. There is very easily you can make stethoscope from your headphone. So this is a normal normal headphone. This I made it at home. Actually, I didn't make it. There's nothing to make it here. This is an app called Think Labs here. And you put double adhesive tape on the mic side, Whereas the mic is there, you put a double adhesive tape because you don't want to actually mic to be too close to the skin. And by putting this double adhesive tape, so you provide some kind of thickness to this mic, and then you place it near wherever your heart is. Okay, on the left side of your body, if you place it, you can actually record the what is called heartbeat. And this app, you can proceed that. So let me see if I can show you. Just give me a moment. I will make you hear the heartbeat of someone's. Okay, I hope you are able to hear this.
Yes, sir.
Now, what is the use of this? Where the medical science is coming into this? Say that you are away from your doctor and you have some kind of discomfort, and your doctor want to see you just by knowing the heart rate will not solve the purpose. He or she needs to hear that heartbeat. You can record this. Actually, this exactly happened while I was recording this. So when I recorded this, I sent it to my doctor friend, and he said that this heartbeat is somewhat looking abnormal. That person is probably have some high blood pressure. Just by hearing that heartbeat, my doctor friend could say that. And this graph which you are seeing here, where I am moving this red laser light, you can see it is giving you this something called cysteine diastole of the heartbeat. Some some nuances in that heartbeat can be represented by this app. It also gives you Fourier transform of that heartbeat. Actually, it tells a lot to the doctor. Wherever there's abnormality, they will be able to identify using that or by hearing that. So, and this is very easy to do. This is called phonocardiography. This whole thing is called phonocardiography. You have a phone you are using for some cardiac purpose. So this is called phonocardiography. But extended use is even better. This is a pocket ECG, electrocardiogram. These gentlemen have made this again using this headphone. So what your headphone does, when you speak through a headphone, these sound signals are being processed, is actually being converted in some electric signal, and from that 3.5 millimeter jack, it is being fed into your phone, and that's how your phone reads it. Okay, so your mic, your headphone can detect an electric signal, and your phone is going to hear only that electric signal. So you cut your phone, you cut those phone part of that headphone. Okay, you will only sacrifice one headphone there. So if you are lying somewhere in your house, something which is not being used, some headphone you use for that, and you extract out only the mic part of that. Okay, so when you open that mic part, you will find two leads. You attach these two leads through a this is some coffee spoon. Okay, and this is a resistance which you have to put, because your headphone will not be recognized unless it has that phone part. So the headphone which you have removed, the phone which you have removed, which you put in your ear, that you have provided by some resistance here. Just put some 10 ohm resistance or 5 ohm resistance here, and it will start working here. And then you put two fingers here. You can increase the conductivity level here by applying some some salt solution and all. So what does an ECG do? It actually detects electrical signal from your body, and when you are putting your fingers in this spoon, this is also detecting electrical signal from your body. Just through this headphone, this modified headphone, it is being fed into your smartphone. And these people have developed this app, Think Labs, and they are able to detect the ECG. Now, this is still in nascent stage, but the implications are revolutionary, I will say. There are in remote part of the country where there are no ECGs in the labs, in the hospitals. It's so easy to make. Actually, I tried to make it, but mine was not that successful, but I'm sure that I was making some mistake. Hence, I was not that successful. But you can try that. And that paper is also freely available, so you can read that. Anyway, so I just wanted to summarize by giving you examples which are not just limited to some experiment which you can do at home. There are some sophisticated experiment which you can do in your labs, and there is also they're coming into this medical field also. Okay, and this is for further readings. Those phonocardiography experiments, they are here. They are two by Thomas, L.J. Thomas. Phonocardiography. This is for ECG with a smartphone. This is for to detect your heartbeat. So I just want to tell you one more thing here, that it of course opens a very exciting opportunity, exciting possibilities here. And whenever you are doing some experiments with a smartphone in your class, I'm sure a student will like it. They would like to do that things in the class. Other than that, they are reviewing your lecture online while you are teaching them. They're reviewing under WhatsApp group or Twitter and I don't know where else. They will also like to do that. Why not to make good use of that? Okay, sometimes it can be used in very sophisticated way for some very precise reading. Sometimes it can be just used for some to verify the principle, as I said. But nevertheless, the opportunities are enormous. There are already something like 600 papers just in these 4 journals, like American Journal of Physics, European Journal of Physics, Physics Teachers, and Physics Education. I was checking out only these 4 journals because my main interest was in physics. I'm sure there will be many in chemistry, in biology, and I don't know where else. So why should we be left behind? Though some of these papers are also written by students. Okay, so with some minimal setting, you can carry out some small research project. Some I have already given you here, and then probably you can have some some good output out of that. Nevertheless, this field is expanding like anything, and I think that student teachers should grab this opportunity. It will go on for next 2-3 years definitely, and you should come out with the ideas here. I have just given you, I have just told you what your smartphone can measure, what to make use of those measurements, that where your creativity will come. Okay, I will stop it here, and if there are any questions, I will be happy to take that.
Excellent presentation, Dr. Praveen Pathak.
Thank you.
Thank you. Yeah, it was very interesting and it was totally different from that of the webinars on physics and material science. And I like that ECG.
Yeah.
ECG and it's phonocardiography. I'll just go through the journal.
Yeah. Okay.
Thank you so much.
Yeah, thank you, Praveen Pathak sir. It was a wonderful talk. You are explained very clearly about that the mobile phone app. We had a wonderful opportunity to hear your talk, and this is interesting and enlighten the young minds towards new thought process. It was amazing. Thank you so much, sir.
Yeah, I just want to know one thing. I am just checking out this YouTube link, and is it still working?
Yeah,
I don't see that.
Sir, I will send it in the WhatsApp, sir. So please check, sir. So it
Okay.
is
No, because I am actually right now on this YouTube link and it is not moving. It is still says waiting for to start.
I will send it in the sir. I will send it in the WhatsApp, sir.
That's okay. Yeah. So
meanwhile, the participants, if you have any doubt or queries, so please put it in the chat box or mute it yourself and you ask directly with the sir, to the sir.
Oh, someone is watching from Philippines also. Thank you, Neo.
Yeah, please participants. So if you have a queries, doubt, so please raise your hand or unmute it directly. You ask question to the sir.
Yeah, I will leave my email here.
Yeah,
and if they have any questions, they can
Hello.
always ask. Yes.
Hello.
Yeah.
Yeah, yes, sir. Good evening. This is Dr. Tirupati from SRM Engineering College.
Yeah.
Actually, people used to say that when you have your mobile phone on your pocket near to your heart, That really affects our function of our heartbeats, or it is one, what is that? It's a fake news, sir.
Actually, I'm not an expert in this field, but as far as my experience says, it doesn't affect that. Okay, there may be some other anxiety comes up when you are checking your phone regularly. There's something called nomophobia.
Yeah.
When you don't have your phone around, then it is actually people keep checking it. So I think those kind of things might be affecting your heartbeat. You're exciting when you miss the phone and all, but I don't think any functionality is there. So as far as my experience says, it is just a fake thing.
Because, sir, actually, you said that when you what is that? Hit your tuning fork, it creates some vibration on mobile phone. No.
No, it doesn't create vibration on the mobile phone. It was
Yes.
I was hitting a rod using a hammer,
Yes, sir.
and it was creating a vibration in the rod. The smartphone was just detecting that sound, just like when you are speaking right now, probably from your phone. I'm able to hear that.
Yes, sir.
So that has happened with any phone. So it was not creating vibration in the phone.
Yeah. Yes. Thank you, sir. Thank you.
Okay, someone asked, can these experiments be integrated for chemistry experiments like reaction rate, quantitative analysis, etc.? Well, I have not checked out for this particular purpose, but there are some chemistry experiments. There's something called colorimetry, not calorimetry. It is called colorimetry, means it can be used to detect the colors and all. But if you just go to Journal of Science Education, Chemistry Education, JC and all, there are some experiments for, I think, using spectrography again, spectrometer. So you can actually check out that. If you leave me your email, I will send you this 1 or 2 papers there. But not for this particular reaction rate. I'm not sure that. Okay, but you should just check out that. You just search chemistry experiments using a smartphone. You will find thousands. Not in thousands, at least in hundreds. No, you send me your email on my email. Okay, I will send you that.
Yeah, any other participants? So please, if you have a queries, please ask.
Okay, people are writing their emails. I just want to tell you that if you want something, you send me an email. Don't just write it here. Okay.
Yeah, in the chat box, no need to put it in your mail. So directly, if you have a queries, please write to sir.
Yes, sir. Sir, one more question, sir. Actually, this is again Tirupati.
Yeah.
As you said that mobile headphones can be used to record the phonogram, no?
Phonocardiography, yes.
Yeah. How accuracy is that, sir? Percentage of accuracy?
For the ECG part, it is still in, so that paper came out in 2019. So that time it was just in nascent stage, as I said, but now they have tied up with some company. So I'm sure that they must have come with some very good resolution and all. That's how they have they are bringing some pocket ECG based on the same principle. So I'm sure now they must have improved it now. So actually it depends on the sensitivity of your headphone also. If you're using some cheap headphone, sensitivity will not be higher, but something like, iPhone and all, this sensitivity is very high, very good. Okay.
Okay, sir. Okay, thank you.
Okay, I believe there are no questions.
Yeah.
Someone has raised hand. Uday Kumar.
So please unmute it yourself and ask, please.
But someone asked that, I don't know if I can, I should be giving it here. I would like to Bachelor of Research. There's nothing called Bachelor of Research. You should go to some BS, you should do some proper, BSc and MSc courses from renowned institutes, just like, so you can just, one of the institute which I'm talking is also SRM. There are ISRs, NISRs, IITs. So you should go to these places. You can go to engineering, and then you can also do five-year MSc or 4-year BS. And after that, you can go to PhD and all. So that will be the traditional way. The colleges, that will depend on your capacity and your performance.
Okay, so if there is no more question, so thank you, sir, for nice presentation. So you have explained how we can use our mobile phone for performing physics experiment and for as a medical instrument too. So it was the eyes-opening session for all of us. So it was very excellent session by you. So thank you, sir, for presenting this to us. Now, I would like to request Dr. Ranjit, Assistant Professor, Department of Physics, SRM IST, to present vote of thanks. Sir. Sir, please unmute yourself. Ranjit, sir. Ranjit, sir, please unmute yourself.
Audible now?
Yes, sir.
Yes, sir.
Good evening, everyone. I am Dr. S. Ranjit, here to present the vote of thanks for today's webinar. I would like to thank our guest speaker, Dr. Praveen P. Pathak, for delivering a talk and enlightening us with his knowledge. Today's webinar was full of knowledge and interesting things. It gives deep insights into the topic and also revealed some interesting mobile applications for some basic experiments. The point where Dr. Praveen Pathak sir told us about the smartphone-based experiments was really informative. I am pretty sure that the precious knowledge that Praveen Pathak sir gave us will definitely help us. Once again, I would like to thank Dr. Praveen Pathak sir for taking out his time for his busy schedule and enlightening us with knowledge. I would like to thank the Honorable Chairman, SRM, IST, Ramapuram, and Trichy campuses, and extend my thanks to Director, the Dean ENT, Vice Principal Academic, and Vice Principal Admin for giving permission to organize this webinar session and inviting us to conduct this webinar. I want to thank Dr. Panikumar sir, Professor Head, Department of ECE, providing the Zoom platform and officially for helping us for streaming in the YouTube. I extend my gratitude to our deep department faculties and research scholars for providing immense support to make the webinar successful. Finally, I thank all the participants for showing the interest in this program. I thank you all. Thank you, sir. Thank you, Pathak, sir.
Thank you. So I will leave now. Will that be okay?
Thank you. Thank you so much, sir.
Thank you.
Thank you, sir.
Thank you. I will leave. Thank you. Bye-bye.
Thank you, Doctor.
Thank you, sir. So participant feedback link is provided in the chat box. Please click and provide your feedback. Dear participant, the feedback link is in the chat. Please fill the feedback form.
Hello, ma'am.
Dear participants, if you have submitted the feedback, you may leave the meeting.
Okay, ma'am.
Hello, ma'am. Can I leave from this meeting, ma'am?
Yeah,
Yes.
please leave now.
Okay, thank you, ma'am. Thank you so much.
வந்துரு ஏன் இவ்வளோ நேரம் முன்னாடியே வந்துருக்குறாங்க.
फीडबैक नहीं मिलेगा अगर मैम
Yes, Rudilende. So the feedback link is posted here. So please.
Right, sir.
We close, sir.
Close class, sir.
யாரும் இல்ல
யாரும் இல்லை சார். Thank you students, thank you for joining.
Yeah, thank you all. Thank you.
सर फीडबैक लिंक कहाँ है?
Yeah, feedback link you didn't fill the, so please wait. I will. Yeah, check it in the chat box, please.